I've now completed the wiring of the manual antenna tuner that I've been rebuilding. Before I do some testing, here is the front panel, the two variable capacitors around 450 pf and two smaller variable capacitors in parallel for fine adjustment, a rotary inductor with about 17 turns, 10 microhenry in value, over here a switch which selects bypassing the tuner through the tuner and dummy load, and down here a range switch for the power meter, 10 watts, 101 kilowatt, forward and reverse selection. Here's a closer look at the meter itself. I've just put my own scale on an old VU meter. It's got some SMD LEDs across the top for illumination. It seems to the scale seems to work quite well. This is the front panel, originally built around 1972 or 73. It's had quite a few years use, as you can see. So it's time to rebuild it and tidy it up a bit. Here's an inside view. All the controls go to the front panel via insulated couplers. This section of the tuning unit has high voltages on it when RF's going through it, so you don't want any of that getting to the front panel. So the knobs are isolated from the high voltages using Delrin and Perspex rods as couplers. Here's a closer look at the shaft couplers, Delrin and Perspex rods. The Perspex is a little bit stiffer than the Delrin, so in some of the tighter controls I've used the Perspex. Here's a view inside the case. The two variable capacitors, the rotary inductor, a ceramic switch, good quality, two wafers wired in parallel, the Stockton bridge, a switch over here which switches in additional inductance. The additional inductance down here, and it operates a relay which is just underneath there, the back of the meter. The output of the Stockton bridge feeds the meter via a number of trim pots for the range adjustments. You can see it down here, and there's a little label there just to make it easy for me to remember what the actual trim pots do. If you touch the wrong one, you end up having to start all over again. This is the back panel. The three connectors, dummy load, input and output, XT60 which I use, and a 2.1mm for external battery, and a little observation hole for the LEDs. The unit doesn't consume a lot of power. The main reason for the power is the relay that's used to switch in the additional inductance from the front panel switch. Originally it was meant to be switched from the front panel, but to simplify the wiring I added the relay. The relay only draws 20 mils and the rest of the LEDs around 10 mils each, so you don't need a lot of power. When going mobile or camping, it'll operate without any power, providing you don't need the additional inductance. Most of the time I only use about 3 or 4 turns of the rotary inductor. On the side I've added a laminated label which tells me what's inside the box. The Stockton bridge, the various components around the meter, and a simplified layout of the T-tuner components, just for reference, for whenever I need to remember what's inside. This is the switch that turns the additional inductor on and off. It's an old pot, so it actually turns, but I'm only using the switch at the rear. So there's the extra inductor, 8.5 microhenry, adds to the 10, giving you 18. That's switched in, switched out. Basically it's in series with the bottom of the rotary inductor, which normally goes to earth, but it goes to earth via that inductor, the additional inductor. What the relay does is shorts out that inductor. When I pull the switch, the short is removed, and so we now have two inductors in series, and that's how that works. The relay is a good quality relay, a Matsushita ST1-D12V DC. There it is down there. There's a little LED across it, which you might just see there on the other side of the board to show me that it's I've got power down to the relay. Here's a quick look at the underside. You'll see the homebrew capacitor there, the Johnson, and a bit of the wiring. Not much else to see underneath. Just a quick demo, tuning the 80 metre 40 metre trap dipole to 20 metres, 14200. I've just got it set up here. I'm just going to run 10 watts, power is 2. So I've got the meter switched to 10 watts and to the dummy load, and just set it up for around 10 watts, which is just about there. So the SWR direct is around 3:1, as you can see there. So I'm now going to switch the tuner in, and you'll see it's a lot less. So I'll just tweak the controls while we're watching that meter. That's C in. There we go. C out. And the rotary inductor, you've got to try and use the lowest amount of inductance in a T-tuner for the least loss. So there we go there. Well, it's pretty well knocked back now. The trim controls won't do much at that level. On the 706, the SWR reading is quite low. If I turn the go direct, you'll see that pop up. And that's what that says, 3 to 1 as well. And that's with the tuner in. Here's a view using my digital power meter. As you can see, it's 1.10. If I adjust the fine controls, you'll see it move. If on the coarse controls, it's not quite so easy. So I'm just tuning the trim, probably a few degrees actually. You can see that's the C out trimmer, and this is the C in trimmer. That's about 10 degrees movement on that shaft, so it's not a lot. You can see it's down to 1.10. The power is 10.6 watt. One thing you can do with this type of tuner, it's a bit sharp, so if you wind the audio up on your rig so you've got plenty of noise, you'll notice that you can actually pre-select an area. See it come up there? That can be quite handy, just to get a pre-selection. Once I finish tuning the tuner up, I tend to write down, I like to write down the values for the frequency, whatever power I used, the value of the SWR without and with the tuner, the value of the capacitors using the scales that are on the front of the tuning unit, and so on, just for reference. And later on I can go back to those values, and I usually find they're pretty close.